Hello and welcome. I think it is working now. Well, we lost 10 minutes of time, but I'm going to, I guess, recover that somehow. So let's get started, and start from the beginning. Uh, so, anyway, today is Friday, April 17th, the day after our quiz. We're going to go over the quiz question a little bit, and then we'll talk about mastering physics. Remember, your mastering physics is due tomorrow. So far, only 7 of you have finished mastering physics. And I think like 19 of you have turned in your parallel resistor lab. I was hoping that you would turn in your parallel resistor lab by Tuesday, because we kind of told you to do that and went over it on Tuesday. But only 19 of you did it, so I didn't get to grade it, which means the grading have the lab due and mastering physics due. Get that done today. There's no reason why you should have waited to 3 weeks to turn in your parallel resistor. Turn it in already. Get it done. Let's get our grades up. Go. All right. So the quiz question had an unknown resistor R, and one of them you knew was 12, and then you had various voltages for your battery. Okay, so since you don't know the resistance of the second one, then you can't just add them up, right? Therefore, you have to do Ohm's law instead. Okay, Ohm's law tells you that V equals IR, so you can solve for the resistance. R is the voltage over the current. So if you want the total resistance, rec, which is the total, then let's go and use the total values. Total voltage over total current. Right? And so using Ohm's law, you can it's almost like an alternative method of finding total resistance. Okay? We know these are in series. How do we know they're in series? Well, whatever current that comes out of the battery will eventually go through resistor 1, here the 12 ohm. Time you have current going through your system, and these currents are the same, and it's the same current going through both of them, then you can say that both of these resistors are in series. Okay, so one of the question was find total resistance, find rec, and so you should have used Ohm's law to find it because there's no other way. The other question, the follow-up question, is to actually figure out what the unknown resistance R is. Okay, and this is the one that a lot of you missed. Some of you just wrote down rec again. It was not asking for total resistance on the second question. It was asking for this unknown resistor R. Now, since they are in series, they're supposed to add up to the total. So what you could do, what you should have done, is find the total and then just subtract 12 from it, because that's the first one here up top. And when you subtract 12, whatever's left over must be, reposition my chair, must be what the unknown resistor R is. All right. So then we had the parallel circuit problem. And why are they parallel? Well, they're parallel because when the current comes into this pink junction here, a fork in the road, it'll split up into two parts. Some of it will go through with the 100, some of it will go through the 50, and then after going through them, it recombines again. And this recombining again is very important. This recombining again is what tells you that they are parallel. It's not just splitting up, but it has to recombine right after passing through them. Otherwise, they're not parallel. Okay? So if there were other resistors in the way, then they are not parallel. It'll be a complex circuit. Ooh, we had a drop off. Hello, are you still with me? Type in chat if you can. You got one yes. Yay. And Chris can. Okay. So when they're parallel, you have to use the parallel rule, which is the 1 over 1 over rule. 1 over the reciprocal added together. But if you have two resistors exactly in series, if you have two resistors, then you can use the product over sum rule. So doing the 1/1 for two resistors is the same as taking the product divided by the sum. And you should always remember that when you do have no curve. When you do have parallel resistors, the total will always be less than what you started with. So since we had 100 and a 50, it's going to be less than 50. Because anytime you do parallel resistors, you're opening up new lanes on the freeway, and so even opening up new lanes will, of course, send more cars per second, more charges per second can flow in your system. Even though there is a resistor in the way, it doesn't matter. Just because there's a new lane, it means we can definitely 50 ohm resistor. What is the current at the 50 ohm resistor I? And it's I2. I went ahead and labeled the resistors R1 and R2. So we're trying to find the current here at resistor 2, the 50 ohm resistor. Okay. Of course, based on the structure of the circuit, you should know that it is definitely not the total current, because the total current split up into two parts, so it has to be a portion of it, some fraction of it. Okay, you can use ratios if you're clever. You can see how the resistance is a 2-to-1 ratio, so therefore the current will also split up 2-to-1. Or just crunch it out using math. Okay, we know they're parallel, therefore they have to have the same voltage. V total equals V1 equals V2. So V2 is whatever the battery is. V of battery. Okay. And if we want to find I2, the individual current, then we'll use the individual values. So we'll use V2, the voltage of resistor 2, which is the same voltage as the battery, divided by R2. And that was all. Okay, so the voltage of the battery is the voltage of the resistor, and you just divide by the resistor to get the individual current. So depending on your battery voltage, you may have different values. All right. So that was pretty much the quiz. We did okay. I was saying how the unfortunate part is that it's kind of hit or miss. So you either got the full 5 points for that section, or you didn't. There was 5 questions. They all were 5, 5, 5. Yeah. We had a couple of 100%. So that was really cool. Good job, whoever you are. And then a lot of people got 80s, so 80%, which is not bad at all. And then some less fortunate scores were also there that skewed the results a little bit. For those of you who got lower scores, if you try to binge watch all the physics videos before the quiz and try to learn everything in one day, you're gonna have a rough time. Do it in pieces, in morsels. You should stay with us every day, one video a day, and continue to build your knowledge a little bit at a time. If you try to do it all at once, it's not going to go well. All right, with that being said, let's shift our focus to mastering physics, so we can talk about combination circuits, okay, where we have both series and parallel parts to it. You did not do that, Georgia. Very good. You're going to stay with us every day. Although our numbers have been decreasing every day, I'm not sure. I'm kind of concerned. I hope that people are still watching. It's just hard, I guess. I think yesterday was like the biggest drop. Well, I guess you guys were taking a quiz, but all my seniors were sad because they got the email from Mr. Hussey. Thank you, Chris. You're the best. You're always here early. Perhaps we should just start with mastering physics number 5, because it deals with the combination circuit. So let's do mastering physics MP number 5. How seniors will graduate? Well, they can still graduate. Graduation is is all online anyway, right? Meaning it's all on our Aries system, and then once you complete all of your classes, your required classes and your units, then your transcript is sealed away and sent to the county, LA County, and then they keep that record. And I suppose you'll get your diploma mailed to you. Kind of like going to an online college. Yuck. Minecraft graduate. Ah, yes, we can do a Minecraft graduation. Press space to walk the stage. Uh, yeah. All right. Let's take a look at number 5. I think that's the one that's holding people up, right? Uh, Actually, 7 of you have completed it already. Completed the entire assignment. I feel bad for my cousin and my younger siblings who's going to graduate this year. Ah, yeah. It is very unfortunate they missed out on the activities and stuff. Juniors, you should consider taking AP Physics 1 so you can do all the fun activities next year. Number 5. Okay, so number 5 is a gradual approach in combining series and parallel components together. Where in A, you just have 3 in series. We know they're in series because they're right after each other. So in part A, if you have R1, R2, and R3, depending on your values, well, they're in series. Chat, how do you find resistance, the total resistance? When resistors are in series, what do you do? You add them all, yeah. How's the delay today? Is it better today? I'm using a different encoder setting. Uh, okay, maybe it's not as good as I thought it was. You add them, so rec is only using 10% of CPU. Actually, this is not bad at all. Okay. In part B, you have 2 of them that are in parallel. So parallel resistors. This is B, 5B. Okay. So if you have 2 in parallel, well, we can use the parallel rule. R1, R2. What is the parallel rule? Well, REQ is the 1 over 1 over. 1 over R1 plus 1 over R2, right? And then in part, and then 2 in parallel. Okay. Look at them one portion, one part at a time. All right. If I go in here, of course, these 2, let's label them. R1, R2, R3. These 2 here are parallel. Okay, and once you combine them, you can redraw the circuit in a more simplified model. The R1 is still R1. We did not mess with it. But we can replace this green portion, this green block, with a single resistor. And it would be the same. It's kind of like a black box model. So what resistor can I replace it with? Well, I can replace it with the combination of R2 and 3. We'll call it R23. And R23 is the parallel of R2 and R3. R2 and R3. And after you combine 2 and 3, you can see how it now becomes in series with the first resistor, because there's only one pathway now. And so after you find R23, you can find rec by adding R1 and R23. right? So we went in pieces. First, we did series. If you see resistors are next to each other, you can add them up. If they have different branches, then obviously you cannot. So so let's say I drew it this way. I drew it this way. Or I did this. Okay. Okay. Is R1 and R2 in series now? Ooh. I drew it slightly different. All right. No, they're not in series. Okay. So this, even though I drew it slightly different, is the same as this. Because no matter what, as soon as you get to this junction here, this fork in the road, now there are two pathways. You can either go through R2 or you can take a detour, go downwards, and then go through R3. Right? So that is the reason why this is not, R1 and 2 are not in series. All right. In part D, now it gets, a little, it looks very complex, but if you just look at it one portion, one piece at a time, you should be able to solve it. We have a resistor here, one over here, and then we have a 3-pack, a triplet, triplets. There we go. The triplets here. Then we have a single, followed by a twin pack, a double. Ooh, like Kit Kat. No. Yeah. Well, Kit Kat comes in 4 actually. What's something that comes in 2s? I mean, miniature Kit Kats can come in 2s. I guess. Isn't there something else? No one knows. That's the real hard question. All right, so here's part D. You have 2 in the front and then a triple, followed by on the bottom lane. You got a bunch of other stuff. So let's look at it one part at a time. Let's label them R1, R2, R3, R4, R5, R6, R7, R8. Okay. Now look for patterns. Okay, look at this bottom piece. Doesn't this look exactly like what you did in part C? Whoa. Yeah, it does. So you can do the same thing as you did in part C. Just like part C. Twix, that's it. That's the one I'm looking for. Good job, Angela. Twix comes in 2. So this bottom part looks exactly like part C. How about this triple pack? The triplet. Well, the triplet, the R3, 4, and 5, the triplet looks kind of like. Actually, well, the triplet is all parallel. Okay, let's label. Let's use a different color. What should we use? Purple. These 3 are parallel, so we use the parallel rule. Okay, how are they parallel? Well, notice how after you get to this point, some of it goes through here, some of it goes through R4, some of it goes through R5, but after going through each resistor, it recombines again, and this recombining is the most important part. And so because it recombines again, we know that they are parallel. Zahir, did you play League with Karthik and we did I did a couple of games. You might be able to see it in the video section. If you hit the videos at the top, you can go back. Um, I played with some of my older students have reached out and like we got together. Basically, some of my alumni from 2019. I also have some alumni from 2017. So 2000 graduation class of 2017 have reached out. So we might do a stream with them. And I think the first day when I was setting up, Evan was in the team because one of my students, like they're all, I guess they're all friends, like so he was invited into the game. Yeah, I think Evan, but I don't think Karthik was there. All right. Anyway, yeah, the goal is to actually make an esports team for El Camino, and I will be the esports coach. That's the plan. So I'm training, so I can learn as much as possible, and I'll be the coach for our esports team. All right, let's move on. Purple. I might do another one on Saturday. Uh, some of my senior students need therapy. They're really sad. So therapy session video games. All right, and then of course these two in the front. Look, whatever current goes through resistor 1 has to go through resistor 2, right? So if something goes through 1, there's no other pathway. It is forced to go through 2. And so if the same current goes through both of them, then they are in series. So identify, you know, which ones are series, which ones are parallel, and then what you do is you simplify by, well, adding or doing the parallel rule one at a time. Okay, so let me redraw this circuit. I'm going to redraw this circuit in a simplified model where I will combine everything. So we still have the two pathways at the start. Oh, we got so many messages. Do you play Minecraft? No, I do not play Minecraft. I don't like Minecraft. Because the Hirsch should do a Fortnite stream. Oh, definitely not. I am not into Fortnite at all. Valorant stream. No, no. I don't like games where like literally, you die in like 1 second. It's no fun. uh, is Rudy in your Oh, I don't have an esports team. Someone else. I mean, we have a Rocket League team right now, and so our assistant principal is kind of doing everything right now because there's no one else. But I think eventually, as it expands outwards, I will start helping out. 2K. I don't have 2K. What about an Overwatch team? Oh, I do have Overwatch. I am a Soldier 76 one trick. All right. Anyway, we are getting distracted here. It is Friday, I suppose. But let's finish our mastering physics, and then we can talk about the game stream when I do the game streams. I've colored it blue, and then after the blue, we can replace it with a purple resistor. Purple resistor. And then the bottom pathway is a green resistor. Whoa, look. Oh no, there we go. Come back. So what I claim is that these two are the same circuits. It's just they have different values for resistors. The blue one is the sum of 1 and 2. Let me just use a legend. Key legend. Let's make a key legend. So the blue one is R1 plus R2. We know we can add them because R1 and 2 are in series. The purple one, purple one, the purple one is the parallel of all three of them. So we have to do with the 1 over method. There's no product over sum for 3, so don't try it. It only works for 2. And however, you could do it twice. So you could do product over sum for 3 and 4, say that 3 and 4 are parallel, and then once you combine them, then you can do it again with 5. So technically that is an option. Or just do everything in one step. R3, R4, R5. So once you do the product, the 1 over method, you can replace that value with purple. And chat, what do we do with green? How do we solve for the green one? Chris, you're an expert. How do you solve for the green one? Just like part C. Well, it's just like part C. Since they are parallel, you can combine them like the first one, and then you can add the other resistor. Ah, very good, DRZ. So we would do R6 plus the parallel of 7 and 8. And so 1 over 7, R7 plus 1 over R8. So you have to combine 7 and 8 in parallel, and then you can add the first one. Well, it's not calling you out. It looked like you knew how to do this problem. So I was just giving you a chance to shine here. But if you don't, if you don't want the spotlight, then that's fine. Well, now we can see how the blue one and the purple one are in series together, right? So we can combine them. Yay! Let's simplify it one more time. So from the big one, we went to this medium. From medium, we'll go to small. The bottom is still the green, so it's still the same value. That didn't change. But now we have this orange resistor. Okay, and what is the value of the orange resistor? Well, the orange one must be the sum. The green is the same, so we use the same color. But the orange one is the sum of blue and purple. Blue equals blue plus purple. You do not want the spotlight. All right. And finally, what's the last step? Anyone in chat? The last step is to see that now these two are parallel to each other. So one final step in simplifying is to get the total resistance rec, and rec is equal to the parallel of orange and blue and green. How are we going to do this? Let's see. It's equal to the 1 over orange plus 1 over green. All right, we have it all color-coded, and that should be it. Next question is, let's see. The next question is 17. 17, where are you? There it is. 17. How much does it cost to operate a 120-watt light bulb for 25 minutes if the electricity is $0.086 per kilowatt hour? Okay, now we're talking about money, so definitely pay attention, right? Now you can figure out how much money you're spending per device every year. It does add up, right? It might be like a couple of dollars here and there, but it does add up. All right, so here's number 17. Power is equal to energy per time. Right. And so it says the cost is $0.086 per means to divide. Kilowatt hour. What is kilowatt hour? Well, that's a unit. It has kilowatts, KW. Kilowatt, not per hour, it's just kilowatt hour, meaning kilowatt times 1 hour. Okay. All right, so we have this cost, which is a crazy unit. All you're doing is canceling out the units, so it's like a dimensional analysis problem, more likely. How do I cancel out the units so I get dollars by itself? And so what you could do is multiply. If you multiply by power times time, this is power times time, then the power and the time will cancel, leaving you with dollars by itself. Right? You do have to have it in the same unit, so we have to either convert the power and the time or convert the cost. Let's go and try converting the power and the time instead. Okay, so you can see the cost is in kilowatts and the time is in hours. So you have to convert the power to kilowatts and the time to hours. So that way the units can cancel. Let's see, 120 watts is equal to how many kilowatts? Well, 1 kilowatt is 1,000 watts, so divide by 1,000. This gives you 0.12312 kilowatts. And then the time. Well, the time is only 25 minutes. How many hours is 25 minutes? Well, there's 60 minutes in an hour, so let's go and divide. This would be 25 over 60 hours. How much is that? Divide by 5. Let's see, 5 goes in 25 5 times. 5 over 12? 5 12s. What is 5 12s? 11%, 9%, 8%, 8 times 5, 40 something percent. 42? 0.42 hours. Ah, the answer to the universe. All right. And so now, if you have kilowatts and hours, you can just multiply them now you can multiply all three numbers. So multiply the cost with the power in kilowatts and the time in hours, and that's it. All right, let's go to number 18. This is the one Christopher wants. Let me know if it's the same one, Chris. It says a 54 ohm resistor is connected to a battery. How much energy is dissipated by the resistor in 5 minutes? All right, so if you want energy, you have to use the power equation. Power. Mastering Physics 18. We have power is equal to IV. Power is equal to I squared R. Power is equal to V squared over R. But from last semester, you also know that power is equal to energy per time. And so combine everything together. If you want time, no, you don't want time, you want energy. Energy is equal to power times time. How do we find the power? Well, we have resistance and we have voltage. So since we have resistance and voltage, let's go ahead and use this equation, V squared over R. So energy must be equal to the voltage squared divided by the resistance, and then multiply everything by time. And that should give us the energy. Okay. Now your time has to be in seconds. Use everything in standard units. So V in volts, R in ohms, and T in seconds, S. Right, so here we're using equations, so definitely convert everything to SI units and then plug and chug. So why didn't I do that in problem 17? Well, problem 17 was just a unit conversion problem. Because the cost was given in kilowatt hours, I decided to convert the power and the time into kilowatt and hours. I could have done it the other way. I could have changed the cost value into watt seconds instead of kilowatt hours. But that would be more work than just converting the power and the time. All right, number 19. A 90 watt light bulb operates at a potential difference of 90 volts. Find the current in the light bulb. Okay, power. So now we're just using power equations. For 19, we want the current. So let's go and use power is equal to I squared. Well, IV, right? IV. And I therefore is equal to power divided by voltage. Chat, what are the units for power? It's energy, Chris. Energy is in joules. Energy is in joules. J. All types of energy is measured in joules. Power is measured in watts. So just take the power, which is J/S. Yeah, J/S is watts. So use watts. Use watts. So they give it to you in number 19. The power of the light bulb, in my version, it's 90 watts. And then the voltage is also given. All right. Part B says find the resistance of the light bulb. Well, so that's part A. There we go. Part B, find the resistance. We can use the other power equation. Let's see. Power is equal to V squared over R. And if I wanted R is equal to, do the old swaparoo. Make sure you put a 1 underneath the power P and then cross multiply. This gives you V squared over P. The old switcheroony. Just switch R and P. And so the voltage is given, the power is given, so it's V squared over P. Anything else? C, it says if the bulb is replaced with one whose resistance is half the value, is its power rating greater than or less than? Okay, so now we are replacing just the resistance value of the bulb. We're not changing the voltage or anything. So C, power is equal to V squared over R, and it says what happens when the resistance is less when R goes down, when the denominator goes down, when your denominator is smaller, what happens to your fraction? Well, interesting. power rating of the new bulb is now greater than, yeah, this one goes up. Fraction goes up. It's now more. All right. Well, what factor is the power rating? Okay, so if I cut the resistance in half, so part D, now you have to do numbers. So if there's a 1/2 here in the denominator, what happens? If you have a 1/2 in the denominator, that's the same as having a 2 in the numerator, right? So it's double. If you have half the resistance, you double. Two circuits. Ooh, now we have diodes. Diodes are really cool. We will definitely talk more about diodes next week. Mastering, but here's an introduction. Actually, I think I'm going to, yeah, well, there's only one part to it, so I guess we can leave it. Number 20, a diode is the arrow thing. Okay, and some diodes emit light. We call them light emitting diodes, which are LEDs. Now a diode is like a light, but the current can only go in one direction. Unidirectional current. But not all diodes are LEDs, right? LED is just a type of diode. Diode is like an umbrella term. Unidirectional current, meaning based on the direction of this arrow, it tells you that current goes that way. I can go in only one direction. That's what unidirectional current means. Because if it tries to go the other way, it hits this wall, the vertical line here. All right. So we have circuit A, circuit B, blah, blah, blah. And let's see our circuits. So we're just using the concept of either the current can pass through or it can't. In circuit A, we have a battery, we have resistor R, we have the diode facing down, meaning it could go downwards. We have resistor R, and then we have another branch, like so, and they're all R's. Okay, and then this is A. And circuit B, there's a battery, a resistor. Now the diode is now facing the other way. Let's use an arrow. R, R, R. Okay. So the current, of course, comes out of the positive end. The positive end is the top side. So this is the plus. It goes out through. Now we're at a branch. Some of the current, well, a lot of the current will pretty much go through here, path of least resistance, and then go back into the battery. Yay. Right? But notice how in the other one, current comes out of the plus end, it'll go through the first resistor, gets to this fork, right? The current can't go through this way because it hits a wall. This wall here blocks it off. So now the current is forced to go through the other detour route, like so. Okay. In circuit A, we had some parallel. So anytime we have parallel, the resistance is always less. In circuit B, because of this diode, this pathway is basically blocked. Circuit B looks like a series circuit, where you have 3 back-to-back-to-back resistors, because this pathway is blocked. And so, of course, the series circuit will always have more resistance. So REQB is greater than the resistance in A. And so if B has more resistance, it must have less current. Current in B must be less than the current in A. All right. I'm going to just remove 21 and 20. No. Actually, you should be able to do it. 21 is the same thing, right? Just look at the pathway in A. It has to go through all of the resistors. So 21 is a similar concept. We have battery, resistor, 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 diode, resistor, pew, pew. In the first one, current can go through here, it can go through here, it can go through here, and then it will combine. Okay. Whereas the other one blocks the current. So like so. And you might be thinking, wait, current can only go through here and here, but when it tries to go through here, it's blocked. Oh no, it can't go through that way. You might be thinking, oh, because I can't go through that way, there's less resistance. That is actually the opposite. What you're doing is you're blocking off pathways, because there are less pathways. There's, imagine like a freeway. There are now less lanes on the freeway. You know how when there's an accident and and then one of the freeways are blocked off, and usually it's like the first lane near the divider, right? So now everyone has to swerve and go to the other lanes and then come out. You know how that slows down the traffic? Same thing. When you're closing down pathways, you're actually increasing the resistance, not decreasing it. So B, here's A. The resistance of B is greater than the resistance of A. So it's actually the same answer. All right. The rest is pretty simple. Blah, blah, blah. All right, cool. All right, I think that's good enough for today. Make sure you turn in your lab number 2. Finish up your mastering physics. They're all due. Hey, that rhymes. I wish I could do this all the time. Tomorrow. But get it done today so you don't have to worry about it tomorrow. Tomorrow we can do some game streams. Yeah. Game streams for people who need therapy. I'll see you next time.